Welcome, everyone. My name is Somaya Sadat. I'm the Assistant Director at the Center for Analytics and AI Engineering at the University of Toronto. It's my absolute pleasure to welcome you all to the seminar today. Before we start, just a reminder that this seminar is being recorded. A link to the recording on our YouTube channel will be shared with you all after the seminar. And I also ask that everybody please type in their questions in the Q&A box, and we will get to them at the end of the seminar. Without further ado, I'd like to ask our moderator, Professor Chi-Guhn Lee, to introduce our speakers.
Thank you, Somaya. Welcome everyone to Carte Industry Seminar Series. This is Chi-Guhn, professor in the Department of Mechanical and Industrial Engineering. As Somaya introduced, I am acting as the moderator during today's seminar. Let me introduce a team of speakers. We have Gary Bogdani, Head of Collective Intelligence at Unilever. Gary did undergraduate studies in Chemical and Industrial Engineering from University of Tirana, Albania, and has more than 20 years of business experiences, of which 17 years at Unilever. Gary leads the Collective Intelligence team at Unilever. Next up, we have Jing Guo, Forecasting Data Science Product Manager at Unilever. And Jing is actually our alumnus and did an MASc in Industrial Engineering. And as part of Collective Intelligence team, Jing is leading the data science work for both demand forecasting and pricing work streams. Last but not least, we have Dr. Armitage from Larus Technologies, who received his PhD degree in physics optoelectronics from the University of Cambridge. He's an expert in AI and ML with 4 publications and 1 patent. Today, this team of presenters will share how Lumos, Unilever's AI-driven decision support system, can turn big data into actionable investment recommendations across Unilever's 1,500 products, so that Unilever can maintain the lead in the competitive retail market as of today. Without further ado, let me invite Gary to open the floor. Please join me to welcome Gary.
Thank you. Thanks, Professor Lee. Thank you so much for Carte for organizing the seminar. I'm very pleased to be here. We're going to go through a quick introduction of the agenda for today, and then we'll move on with the presentation. Next slide. Before we start, can I get a sign that everything is visible from a point of view of the presentation? Everybody is seeing it? Okay, yes. Perfect. Thank you so much. So in terms of the agenda, what we'll do is we'll talk a little bit about our company, Unilever, and then I'll give a brief introduction to what collective intelligence is and how we're operating in the innovation and research space. And then I'm going to pass it on to Jen and John to talk about the trade promo optimization system. And we're going to divide that into 2 modules. We'll talk about our point of sale forecaster, as well as the promo optimization engines. We'll close with some of the lessons learned and an overview of what our plans are for the future. Let's move to the next slide. So about Unilever. We are one of the world's largest consumer goods companies, and at the core of our business is our purpose of creating sustainable living commonplace for the society at large. Focus is not recent. Of course, a lot of organizations have sustainable goals, and we do for several years. But we go back, way back to our founder, William Lever, that launched Sunlight Soap in Victorian Britain to help tackle infectious diseases. So the sustainability goals have always been with us, and they are part of the work that we do across the world. Next slide. We have a we're a really large global business. We have a large footprint. We are in 190 countries in the world. Every day, 2.5 billion people use Unilever products. In many of the countries we've been there for over 100 years. Like think of India, Indonesia, Argentina. And in fact, more than half of our turnover comes from emerging markets. Specifically in 2020, our turnover was 51 billion euros. We have 25 million strong global network of retailers, from mom and pop stores all the way to big retailers. And we estimate that across our value chain, we can reach 3 billion people. And then in Canada, we are sort of a mid-sized market for Unilever. Our turnover in Canada is 1.6 billion Canadian dollars. We are also the second largest advertiser in the world. Next slide. Two things we're really proud of, two core pillars of our business is our brands and our people. When we talk about our brands, we are actually producer and a promoter of leading brands and favorite brands around the world. In this slide, you see some of them, but I'm sure everybody has at some point in their life used a Unilever product. And if you have not, then you should be using them. Let's move to the next slide. As I said, core to us is our people. They make our business what it is. We have 149,000 employees worldwide, but more importantly, 93% of our leaders are local to their market. So we call ourselves a local global company. We're rated #1 in fast-moving consumer goods graduate employer of choice in 54 countries. And what's important for us, really, we want our employees to reach their full potential. We are creating capability through lifelong learning by inspiring, enable people to never stop growing, and they take also charge of their well-being. We also unlock capacity for growth by being truly agile, by simplifying and leading for an inclusive future of work. And then lastly, we deepen our culture of pioneer by driving performance through leadership and innovation in all we do. And indeed, the collective intelligence space that we've created is a testament to the investment that Unilever is doing in its people and in developing the future fit organization. We have a big scale, and we are also using our scale for good. The size and scale of Unilever makes a huge difference. In 2010, there was a crucial year for us. We codified the work that we're doing in the Unilever Sustainable Living Plan. The plan was a very ambitious plan with very ambitious goals to first decouple our growth from our environmental impact while increasing our positive social impact. It had over 70 time-bound sustainability targets. I'm going to give you some examples on those targets and what we're driving today. One big target was to improve the health and hygiene of people. Since 2010, we've improved the health and hygiene of 1.3 billion people worldwide. We also have achieved 100% renewable grid electricity globally, and 67% of our agricultural raw materials are now sustainably sourced. Furthermore, through several initiatives, we've empowered women. 2.63 million women have been empowered through our programs that promote safety, develop skills, and expand opportunities. We also have achieved zero non-hazardous waste to landfill across our global factory network. By the end of 2014, we've hit this goal every year since 2014, and especially also in 2020, which was a very difficult year for everyone. And last but not least, we've done a huge, we've created a huge impact in plastic packaging. In 2020, 52% of our packaging was reusable, recyclable, compostable. We achieved that in practice and at scale. So that means actual recyclability. We were the first company in our industry to commit to ensuring that 100% of our plastic packaging is reusable by 2025. So very ambitious goals in that space. And more importantly, for us who like data, 80% of our sales volume in scope for plastic packaging and reporting is we do have data for, and then we're working to increase that further. So next slide. Let's talk a little bit about the collective intelligence space that I've been leading for 4 or 5 years now. We started this space as an innovation and research space focused on advanced analytics, AI, and ML. And that has grown over the years to become like a crucial part of our market impact from a data and analytics point of view. This slide shows a little bit our reach from a point of view of how do we operate in this research ecosystem that we've created. I've put there SOSIP and Mitex are two organizations that we've been developing a relationship and closely collaborating with since 2017. And our relationship with these organizations has created like several benefits, for us as a major industry player in our sector, creating talent pipelines, creating research, opportunities, not just for university, but also leveraging the results of that research to create value generating solutions and products for Unilever. With very important impact also in terms of resources that we've engaged. 25 graduate, 10 postgraduate, 12 research teams from different universities over the past 2-3 years. But we haven't stopped at that. Like we've made research and innovation as part of our operation processes that we've implemented at scale. On the right-hand side, you see some of the large partners that we have in the space of innovation and research funded by the federal government. So remember, Scale AI, actually Jin, who's with us here, she's leading a large initiative of implementing demand forecasting in the business as part of a consortium led by Unilever and funded by Scale AI. So for us, it's really important to actually have an end-to-end view to this, from creating a question, building research upon it, turning that into value use case for the business, and then scaling up and implementing at large scale. Last thing before I move on to where I pass it on to Jin, I want to make sure that you guys are aware that we have several programs running, and we are always in search of researchers and interns in our data science, software engineering, and data engineering teams. Please reference the material that Samaya is sharing in the chat, and then reach out to either Jin or myself if you're interested to be part of our journey. And for this, I will pass it on to Jin. Over to you, Jin.
Thank you, Gary. Okay, so I'm gonna move over to talk about the Lumos ML trade optimization platform. So the trade optimization is the process of arranging promotional recommendations across product, type of promotions to maximize key performance metrics. So here are some of the examples of the KPIs that we use here at Unilever: return on investment, market share, profit, and spend. And then you might notice that they have competing objectives across them. And then for a company at the scale of Unilever, this process is non-trivial due to the scale and complexity of the problem. To put that into perspective, Unilever has over 200 brands and over 1,200 individual products that are currently selling in Canada. You can find Unilever product across all of the major retailers in Canada, which is more than 8,200 stores. And that is more than 5 million product store combination that require forecasts. And each geographic location, retailers, banners will have their own promotional strategy that makes the scale of the promote investment decision incredibly complex. There is a need for an automated and efficient trade promotion optimization tool to support the business users and our retail partners to make better and informed decisions following the monthly sales and planning cycle, to best optimize promotion, to maximize return on investment, and to minimize investment spend. And all of that is really to try to achieve the key objective to bring the most competitive pricing to the everyday consumers like you and I. So to achieve that, we have several requirements to design this future fit approach for trade optimization. So one of it is to forecast in the POS. So we start with the product level demand forecast, and by promo status, each promotion events will need to be profitable, and the competing set of the promo events for a given business level aggregation, so either that is a customer level or customer category level, needs to be within the promo budget allocated. So that's when it comes into evaluating the profitability and asking the question is that, how does this proposed promotion impact the trade spend? And then would a team within Unilever and their collaboration partners on the retailer side be able to afford that promotion? And then looking at the feasibility side, so a business user who come up with a set of recommendations that they would like to propose to the retailers, and then they will have to sit down with the retailer partner to see that if this promotion recommendations will be feasible under the current regulation by the Competition Bureau, and also if it would able to be meet the hard and soft constraints set by the retailers, such as the capacity constraint, the timing constraint, and then also a key component of this is to enable explainability, provide a platform that would support the business users and the retailers to make the most informed decision and transparent decision, so that they are very, very confident in what they're bringing onto the table, and then to support them to deliver value to the retailers. And to achieve that, so we have built an end-to-end AI-enabled decision support platform to achieve this automated trade promotion optimization. And then we bring in multiple data sources, we formulate potential scenarios, and also bring together the competing objectives and formulating them into mathematical equations, into fitness functions, so we can model and optimize. We create different features in order to capture the changing market. We try to capture the shopper performance through shopper profiling. We also track the past and future promotion events to try to explain what happened in the past and also what might happen in the future. And through all of that, we use both the machine learning driven forecasting system as well as the optimization, which we'll share with you in the following slides to complete this and to bring out this optimized promo calendar, as well as the web-based scenario planning tool to support the business users and the retail partners to make informed decisions. Through the support of accurate data insights and technology, make this process more efficient. That will enable the team to spend less time to provide the data supported strategy recommendation for planned scenarios that will determine the optimized opportunity where there's relevant under the constraint that each of the retailers are facing. And then to drive a collaboration process with each of the team to enable the data flow between the Unilever team and then the customer team, as well as across each of the functions within the Unilever team to really try to drive a decision-driven and collaboration decision process. So the demand forecasting is the foundation of the trade promo optimization engine. It means to monitor a range of variables that affect the demand from the historical demand patterns, internal business decisions, and external factors. It uses variables to project future sales under the different pricing and marketing scenarios. For example, expected sales at the regular price versus a promotional price. We also design our model to align with the economic theories, such as the assumptions of price quantity relationship to normal goods, inferior goods, and given goods. The partial dependency of the sales with regard to certain variables will require us to design specific constraints, such as the linear constraint, monotonic growth. So some of the examples that we use are, for example, event duration to measure the promotional fatigue, discount factors, and so on. And as you know that over the past 2 years has been a very dynamic market for Unilever. So we have created different features to try to capture this dynamic market. So coming from the surging sales due to COVID, to the supply constraints from the materials, to the blockade at the Suez Canal at some point last year, and now the oil price, and all of these are shocks to the Unilever system as well as the overall demand, market demand for entire Canada. So we saw like in the beginning where there's market surges, and to the later on people are trading, going to the restaurant versus purchasing food items and to cook at home. So we capture these through the external factors and also some of the features that we engineer. And then the other part is on capturing and then including these business decisions, as we mentioned, the promotions, the pricing, the bundles of promotion, as well as the distribution. And these are some of the factors that we include. And we put all of these together to forecast the demand at each of the retailer level, product retailer level. And then another very key important is explainable AI. So it's very crucial to convince the business users that the model is considering multiple variables consistently with the economic or best business practice. And in particular, the input variables, relative impact and directionality. So looking at the variable that we input into the model and then explaining them and then see like these are the variable that we include and this is how they are driving the forecasting engine, which is the foundation of the promo optimization, is very, very crucial. So some of the questions that people will ask are, what are the influential features for specific forecasts? What features are driving the long-term and short-term forecast? What feature forecast caused by poor forecast? So what are some of the driving factors of the poor forecast? And how can we make that better? And what are some of the driving factors that we can manipulate that's within the Unilever decision realm that can make these, that can lift up the sales? And then how does the model understand the historical data and what are some of the data that is training on that the model is learning? So next, I'm going to pass along to John to talk about the optimization engine.
Yeah, thanks, Jim. Yeah, so here we drive a collaborative customer experience by evaluating promotion recommendations with customers to ensure their customers' promotions are planned and executed to generate the business objectives. Our process is a data-driven approach augmented with a business user and collaborator input. The process starts with understanding the relevant business objectives along with business constraints. Objectives would include like profit margins and market share and so on, while constraints would include like promo frequency, shelf space, and etc. Given the objectives and the constraints, our ML-based optimization approach generates a set of recommendations. One of the optimization approaches we use here is a genetic algorithm. After the recommendations are generated, they're reviewed by our business users, which then drive collaboration with retailers to achieve shared objectives. If our ML approach, business users, collaborators align with the recommendations are executed. Otherwise, the process repeats until everyone sort of realigns. One of the multi-objective algorithms that we use is a genetic algorithm. The company I work for, Larus, specializes in multi-objective optimization for defense drones and retail applications. Genetic algorithms are class of optimization techniques that use biological inspired processes of natural selection. GA are a natural choice for multi-objective optimization problems as they maintain a population of diverse solutions. A multi-objective optimization process can be converted to a single objective optimization process. However, the aggregation fitness functions may be unable to find non-complex solution regions. To simulate an evolutionary process, you need a genetic representation of the recommendation in addition to some sort of a fitness evaluator, which is here that we use like an ML model. Next one. Yeah, so this is like a quick flow chart of a generic GA algorithm. So first in the top left, you start by initialization of population of recommendations. This initialization process could be random, or another process optimization procedure can be used to adjust recommendations with maximizing a single optimal objective. The recommendations of the population are then ranked using a fitness function. Here we use some ML approaches. We then select two recommendations from the current population to produce a child recommendation during breeding selection. A child is generated by performing crossover in a form of genetic swapping between two parents and recommendations. The child then undergoes a series of random mutations in order to bring on new genetic diversity. The child population is then combined back with the parent population, and all the calendars are ranked via some ML procedure. Next, the top N individuals are selected, and the unlucky individuals are removed from the population. This process will continue to create another generation of recommendations unless some sort of stopping criteria is met. Yeah, next slide. Through optimization, we identify combinations of promotional strategies that are best suited for each retailer according to their specific market conditions and constraints. Over many generations of the algorithm produces a stable Pareto front, allowing the user to select the optimal calendar based on their specific business goals. The optimal Pareto front defines a non-dominated viable recommendations. Non-dominant recommendations like recommendation A, B, C, the right-hand plot are solutions where no other solutions exist with consistently better objective metrics. A dominated recommendation would be D, because B is just obviously better. Outputting a Pareto front allows the retailers and Unilever to trade off different business objectives while knowing the solutions will result in optimal objective performance in real time in interactions. Yeah, next slide. Thank you.
So that's the end of our presentation. I'm going to pass it over to Professor Lee to kind of see if we have any questions. Please feel free to use the Q&A section for questions. Thank you.
Okay, thank you, Gary, Jing, and John. Wonderful presentations. And let me go through questions in the Q&A box. And I see one question there, which is, so the question is about technical details, I believe, about the equation on SHAP value SHAP. So Jing, if you can explain a little more technical detail on that concept or value, that would be wonderful. Thank you.
Sure, I'm happy to take that question. So we use the SHAP value to explain the demand forecasting, so kind of like the different variables that we input into the model and how do they drive the forecast. So the SHAP values explain the specific forecast via a linear sum of the expected values of the model, given a sampling of the possible historical features. So that's essentially how SHAP value works. Hope you look up about it. It's really, really cool. And I think that's really revolutionizing how we're using ML internally here at Unilever.
Mm-hmm. Okay, thank you. Thank you for the response. So in the meantime, audience, feel free to input your questions while we are waiting. I do have a question, for Jing again, now that she's on the podium. So I have a question about the prediction process. So in one of the slides that you presented, you showed a forecasting graph, and one graph has POS forecast with features and the other one with forecasted features. So based on the title, I guess you first forecast the features, and from features to POS prediction, that could be according to some pre-established connection. Is that how this is working?
Yeah, so what we do is that when we have a data exploration process. So it depending on what's the business objective. So here in this example, we are looking at the POS forecast. I would say that we're looking more for the POS forecast, which is a general demand coming from the retailers. We also have a separate stream, which is looking at the shipment forecast. And then the shipment forecast is looking at what's the ordering patterns from the retailers to Unilever, because Unilever is a manufacturer, we produce items, and then we send them to the retailers. And the retailers have their own inventory management system. And then so they will need to have a ordering patterns and ordering items from Unilever. And then in this case, what we'll usually do is that we look at the different series, time series data, and then we look for relationships. So we do covariance analysis, we do co-integration analysis. So I think on the graph where you mentioned that you asked a question about the POS and the shipments. So usually we'll do a co-integration relationship between the POS and the shipment to see if there is a relationship. If there is a relationship, we'll either forecast the POS separately, or we'll try to forecast the POS and the shipment. So the latest model that we're using, what we do is that we'll forecast these these series individually. So then, for instance, some of the other series that we use, either that is internal data or external factor that we use to forecast these features separately.
Oh, thank you. Thank you for the technical detail. So I see a follow-up question related to that.
I think I might have deleted it by accident. I tried to answer that.
Okay,
and I deleted it by accident. But yeah, it's not the expected value of the that specific forecast. It's the expected value of the forecast function given a random sampling of all previous historical features from like your training set effectively. So it's not exactly the same. And so then it's basically it's a measure of a random or your expected value. Yes, expected value of what your function basically should produce from all the other historical training examples, and then reference to that specific example. So you can say, this is what I kind of expect that the model should produce. This is what it produced. And this is the sort of linear summation of all the other features and how they contributed to that specific forecast that we're interested in. Yeah.
That's an interesting approach, personally to me. Okay. I've not think of this kind of approach. Interesting. So now that John is on the podium, let me ask a question of my own. So about the genetic algorithm that you are using, how often do you have to re-optimize, and then what is the scale of the optimization problem in terms of decision variables and possibly number of constraints and etc.?
Yeah, so it depends because we can set it up to run it at different levels in different contexts, right? So for example, we can run it across like all of Canada for a specific customer or category or any sort of level in between. And so yeah, there tends to be, in terms of decision variables, I forget off the top of my head, but thousands of them. There's quite a lot of them, and then that's sort of a problem that we end up having, just because the number of combinations that you can get if you do like a brute force approach would just be like kind of impossible to like go through every single. So you have to do some sort of smart search effectively in some context in order to be efficient. Sorry, is that everything? Maybe I missed something.
Okay, thank you very much. So I used algorithm similar to this, not genetic algorithm, but some other meta heuristics. So it was long time ago. So back then maybe technology was not mature enough. So training those algorithms and hyperparameter tune-up was quite tricky, and depending on how we did it, performance was very different. So I'm sure you went through all this process and having this optimally tuned algorithm now. So thank you for that explanation. So I see another question from, so I think this question is about the same equation. So maybe I would like to invite Jing again about that particular equation involving SHAP. So asking about f of x and some of other topics, but I think John addressed that, but he or she is asking about random variables and so on. So maybe we can go back to that question again and then spend a couple of more minutes, if you don't mind.
Yeah, sure. I can go through that quickly. And then so the fx in there, and then I think on the graph it says expected ffx. So then it's the ffx there is our demand function. So it's looking at what we're predicting for our POS forecast. And then you can actually do this at different levels. So you can do this at the SKU customer level, which is what we forecast. But then you can, because everything are linear, so you can aggregate them up to the level that we're analyzing. So sometimes we do annual analysis for a given category, where we do annual SKU level analysis.
Okay, thank you, Jing. So now there is a question about the internship hiring. I believe Gary must be the right person to respond to the question. So Gary, would you comment on it?
I will comment on it, but I'll let Jin, because she is kind of overseeing that process for us, along
Oh, I
with
see.
our data science product managers in there. But the good question. So I would say, if you ask me, there's no criteria, in the sense that we look at a few things. Obviously, we look at the for researchers, the research that they've done, type of courses that they have been involved in. We look at the skill set, depending if we're looking for a data scientist. Obviously, there's a certain skill set and some programming languages that we need the person to have a good command of. I would add, I'll let Jin to go a little bit more in detail on this part, but I would introduce a little bit the way we are managing these internships and this program. To me, there's three fundamental pillars that we are sort of that are in the foundation of this program. One is the ability for us to attract talent, but also to introduce talent to our business. We have a very extensive training program and onboarding program, which is deployed in different fronts, from a point of view of the capabilities and products we manage, all the way to sort of a generic data science training. So that's one. The second one, we embed the interns into specific projects. So they work very closely to our product teams. And then the third is we do measure the results of their work. So everything that we do as a integrated product team has a goal to measure the value that these products are bringing to the business, and the interns are very much part of that journey. So I'll pass it on to Jin to talk a little bit about the hiring process.
Yeah, thank you, Gary. So I think that definitely, if anybody's interested, please do apply. So we are currently looking for interns to join us as soon as possible for the summer cohort, as well as in the fall. And then, so in terms of what we're looking for, it's definitely, as Gary mentioned, that programming skills in terms of SQL, Python. So these are the two, I think, the languages that we use most frequently here at Unilever. And then in terms of the what we're looking for, so it depends on the role that this individual might think that he or she might be most suited for. So for instance, we have data analyst role that we're currently recruiting. So in the analyst role, we require someone to have a data visualization skill, storytelling, presentation ability, and as well as some exposure to software such as Tableau and Power BI will be very beneficial. We also look for research student roles, so then who will be actively participating in building the next generation ML solutions. And then for those people, we have a high requirements from the technical ability and also the academic background. So looking for experiences either in optimization, forecasting, time series, supply chain. So those experiences are very valuable. And then, yeah, so I think that if anybody's interested, please do reach out to Gary and myself. We're very happy to talk to you one-on-one.
Thank you, Jing, for the detail. So now I have one question for Gary again. So this Lumos seems quite powerful, and you seem to have invested a lot of effort and time, and performance seems wonderful based on my personal experience. So this Lumos, is this for global Unilever, not just Unilever Canada?
So yes and no. There's two parts of it. There's obviously very specific objectives where we do support and try to answer business questions that are coming from Unilever. Some of our components that we've built for the platform, though, have now a global visibility. So some of the components, especially on the trade optimization, the work that we've done with our strategic partner Larus, and all the products that we've built in this space are being looked at from global teams to become sort of a best practice and launch in other markets for Unilever. The way Unilever approaches sort of this innovation space is twofold. there is sort of global program or projects that are run and products that are created, and we benefit from them. But there's also market activities, like a market like Canada, that build products that can be scaled and used in other markets.
See, thank you, Gary. So we got another question here. I guess this question can be for John. And the situation that this question is about is something that I also experienced. So when pandemic arrived, I was concerned that the business is bad and all these companies working with us leave the collaboration program. But it was completely different from my expectation. So now during this very volatile time, as Jing mentioned during the presentation, we have pandemic now, war in Ukraine, and all these supply chain disruption and so on. So we are experiencing unprecedented situation now. So what does that mean in terms of optimization and parameter tune-up and from your end?
Yeah, I think just to some extent, I guess there's definitely a lot of extreme and volatile situations that are going on right now. And realistically, we do our best to try to model that and take into consideration the error and so forth that clearly will happen. And so trying to make sure that, we're doing sort of robust forecasts as well as trying to avoid overfitting just a lot of things that just pop up in huge surge in sales that obviously aren't going to be sustained. And so for the most part, there's been some pretty dramatic demand hits that have happened, but then have gone away. But trying to, forecast for, taking consideration inflation and so forth, and trying to model that out is obviously very challenging and difficult, and the error on it is going to be quite high, and even understanding where, and so even understanding even accurately the error margins and how they're going to freeze is also going to be very challenging. So we also try to include in our optimization process things like trying to minimize the and making sure we're making safe bets, right? Trying to, and so at the very least we're not going to we're not risking all of our money in, say, in a volatile environment and trying to hedge it that way as well. And so, yeah, I'm trying to think of specific examples of that. I don't know if I can give specific examples that I'm allowed to give. But I guess maybe the obvious one is just like the COVID purchasing surges. So if you look at what happened, across the Unilever products during the lockdowns and so forth, there's some really big surges that happened, and so Pendley is just trying to make sure we detect those properly and don't assume that's going to happen again. That's like one small aspect.
I think this non-stationarity, synonymous to this volatility is quite a bit of challenge, especially for data-driven project, right? Because the situation is behaving unlike anything in the past, so that historical data does not, represent what's going to happen in the future. Then all these data-driven methods may collapse. So I think this could be, quite a bit of challenge to Unilever team as well. So next up, we have another question about the combination of machine learning, data science with sustainability issue. So from the presentation given by Gary, I realized that sustainability is an important value within Unilever system. So maybe I can invite Gary to comment on this topic.
Yeah, absolutely. I mean, we're on the commercial side, but we've got several programs, especially on the sourcing, production side, research and development, that tie in sort of the machine learning and AI solutions to the sustainability goals. A couple examples that I could give is, for example, we have like a huge program that runs out of the US that's global, that deals with the availability of raw materials and this all the sustainability goals attached to that. There's also in the R&D space, there's several programs that we're doing And then last but not least is the plastic. I mean, we've done you know, a lot of research in that space and used sort of AI and machine learning to actually improve the results towards achieving the goals. For us, that for us is critical, like 100% recyclable by year 2025 for all our packaging. So yeah, very much tying all the innovation and research capabilities we have to our sustainability goals. Yeah.
Yeah, I see. So as a researcher working on supply chain myself, in many cases, more efficient supply chain, sometimes, you know, similar to less, you know, waste and a more, you know, sustainable supply chain. By traveling less and by sending the item to the right place, we can, you know, reduce unnecessary transportation and waste. So matching the supply and demand and efficient transportation system can be a way to improve sustainability. I guess machine learning and data science will be a crucial component in achieving higher efficiency of supply chain. So thank you everyone. So it was a wonderful presentation, and I found you know, many interesting things and initiatives you know, from Unilever, and also I personally impressed by the level of sophistication in their you know, decision support system, in the quality of focusing and everything. So congratulations. And also, thank you for attending this seminar. I think the discussion was very active and a lot of questions. So thank you for everyone. So maybe you can you know, conclude here. So Somaye, do you have anything to say?
No, I just want to thank everyone as well, Professor Lee, Gary, John, and Jing. This was a great seminar. I hope everyone else enjoyed it as much as I did. We do have a question around how the audience can connect with the Unilever's team. So Gary, maybe would you want to?
Yeah, you've got my email there, as well as, or reach out through LinkedIn as well,
Okay,
either
through
to Jin or myself, and we'll be happy to answer your questions and chat more about your interests as well. Yeah.
Okay, thanks everyone. Have a great day and thank you for attending. Thanks.
Okay, thank you everyone.
Thank you.
Yeah, bye.
Bye.